Today we are going to do lesson number 1, which we are going to explore different exponent laws for multiplying and dividing powers. But they have to have a same base in order to apply the exponent laws. So let's take a look at example 1. So in this case, if I have negative 5 squared and negative 5 to the 4, what I can do is I could expand it. So I have 2 of negative 5 and then 4 of negative 5. Okay, so you can expand it. So what you can do is this will equal to negative 5 to the 6. So a short way to understand is that we have a same base of negative 5. And when you're multiplying, you add the exponent. So 2 plus 4 will give me negative 5 to the 6. On the other hand, if we are dividing with the same base, in this case the base is 7, the base stays the same. When you're dividing, you subtract the exponent. So 5 minus 3, which is 7 squared. Now what about number 3? It looks like the base is y. First, what we could do is we could multiply and then we are going to divide. So let's simplify the numerator first. Y, so it's 5 plus 2, which is 7, divided by y to the 4. Now when you're dividing, you subtract the exponent, so 7 minus 4, y is equal to 3. Okay. Now example 4. Same thing here. This is on like long expansion form, but we don't want to do long expansion. We want to do the short expansion using exponent law. So in this case, it looks like we're going to multiply the numerator, but only the same base apply the exponent law. So for the numerator, it looks like the same base is x. And you don't see a number in the exponent for x. That means there's invisible 1 here. So we are going to add the exponent because you're multiplying. So 4 plus 1 is 5. And then there's also invisible 1 for y here. So then y, 1 plus 3, which is 4, divided by x3, y2. So then what you're going to do is you are going to divide the like term with the same base. So in this case, x, 5 minus 3 is 2. And then y, 4 minus 2 is 2. So that will be your final answer. So what are the rules? Well, these two are very important rules that you would want to highlight. When you have a same base of a, what you do when you're multiplying, you add the exponent, m plus n. So to multiply powers with the same base, keep the base and you're going to add the exponents. On the other hand, when you have a same base and you're dividing, you subtract the exponent. So to divide powers with the same base, you again keep the base, but this time you subtract the exponent. These two rules are very important. Okay. Now let's try some questions. So number 1a. Notice how we have a same base. The base is 2. And when they're right beside each other, you're multiplying. So it's 2 to the exponent of 15. You're adding it because you're multiplying. So 15 plus 25. So therefore, it's 2 to the 40. What about letter D? So it looks like my base is y, and because you're dividing it, you have to subtract the exponent. So in this case, negative 10 minus negative 6. And negative negative becomes positive. So y negative 10 plus 6. So therefore, y is equal to negative 4. Okay. When you have a fraction, I would just punch it in the calculator or change the decimal into fraction. So 0.5 actually means 1 over 2. So same thing, the base stays the same, and when you're multiplying, you add the exponent. So negative 1 over 3 plus 1 over 2. So the best thing is the calculator is able to do this. If not, you have to find the common denominator. So it's going to be multiplying by 6 to make a common denominator. So it's going to be 6 to the negative 2 over 6 plus 3 over 6. And then 6, negative 2 plus 3 is 1 over 6. And that should be your final answer. What for letter H, let's simplify the top and the bottom separately. So for the top, it looks like these two are the same base. So negative 3, 7. And then x, 8 plus 16, which is 24. Okay. And then over, I noticed that we have a same base of negative 3 and negative 3. When you're multiplying, you add the exponent. So there's invisible 1 here. So 1 plus 2 is 3. And then we also have a like term here, x and x. Because they're multiplying, it's going to be 10 plus invisible 1. So x to the 11. And after that, we can simplify the like terms of negative 3 this way and x this way by dividing. So negative 3, 7 minus 3 is 4, and x, 24 minus 11 is 13. And that should be your final answer. Okay, so please remember to collect the like terms and simplify the numerator first and denominator, and then put it all together. Okay, now the next question, it's same thing. It says simplify to a single power, and then evaluate means that your answer has to be like containing no exponent. Expand your answer. So for example, letter A, if I have to simplify, the same base is 4, the base is 4, you're dividing it. So 5 minus 2 is 3. And then 4 to the 3 means 4 times 4 times 4, which is 64. Okay, so I simplified and then I evaluated. Let's try letter C. My same base is negative 3, and because they're right beside each other, we're multiplying. Negative 1.2 plus 5.2. You add the exponent. So it becomes negative 3 to the 4. Then you're going to do negative 3 times negative 3 times negative 3 times negative 3. Or you could use the exponent button and you will get 81. Okay. Okay, so you're going to do same thing here. I want to go over letter D. The base is 6. But it looks like we have a square root 100. So let's simplify what square root 100 is. Using your calculator, square root 100 is 10, and square root 49 is 7. So essentially it means 6 to the 10 divided by 6 to the 7. So when you're dividing the same base, you subtract 6 to the 3. So then 6 to the 3 is 216. Now, the next type of question is you are simplifying using the exponent law, but then you're going to evaluate by plugging x as 5 and y as -2. So let's try letter B. So if you look at letter B, I can simplify. So simplify the coefficient first. So it looks like my coefficient is -5 here and 25. So -5 divided by 25 is going to be -1/5. Right? I divided both top and bottom by 5. And then with x, we're dividing it. So we have to subtract the exponent. 5 minus 4 is 1. And then y, 6 minus 2 is 4. So we simplified using exponent law. Next, what we're going to do, we're going to plug it in. Every time we plug it in, we have to put a bracket. So -1/5. So for x, I'm putting it as 5 to the 1. And for y, I'm plugging in as -2 to the 4. So let's see. -1/5. 5 to the 1 is 5. And -2 to the 4 is 16. So when you multiply, you can do -1 times 5 times 16 divided by 5. Or you will notice that 5 and 5 cancels out. So my final answer is going to be -16. Okay. Now let's try letter C. So for letter C, same thing. Let's simplify the like terms for the top one first, the numerator. It looks like we have 4 to the 5. And I do have a like term with x. This one and this one. So what we're going to do is we're going to add the exponent. So x to the 4 plus 6 is 10. And then y squared over, so we don't have any like terms here. So it's like, I'm going to put 4 to the 4 first, and then I'm going to put x, try to put it in alphabetic order, and then y. And then after, we can collect the like terms with 4, these two, and then we have x and y. So let's see. So the base for the 4 stays the same. Because we're dividing, we subtract the exponent. 5 minus 4 is 1. The base stays the same, x. 10 minus 8 is 2. And y, there's invisible 1 here. So 2 minus 1 is 1. But we don't write 1, so 1 is invisible. So I'm just going to erase 1 here as well. And then there you have it. So we simplified, but now we are going to evaluate by subbing in. So for, instead of writing x, we're plugging in 5 squared, and for y is -2. So for 5 squared is 25 times -2. When you multiply all this, you will get -200. So evaluate means no variable, just numbers. So that was exploring exponent law, looking at multiplying and dividing with the same base. With lesson number 2, we are going to look at power of power. So power of power means that they're right beside each other. So for example, let's say we have a to the m. We have a power of power. So when you have an exponent to an exponent, what you do this time, you're actually going to multiply m times n. So as a review, when you have a to the m times a to the m, the base stays the same, and you add the exponent. And when you're dividing, the base stays the same, and you're subtracting m minus n. So let's see. Let's just do a review. For letter A, we have a same base, 4, and you're multiplying, so it's 8 plus -5, which is 4 to the 3. 4 to the 3 is 4 times 4 times 4, which is 64. Now, what about this one? So it looks like we have a same base of 5. The first one we're dividing, so 5 over 6 minus 1 over 3. And then because we're multiplying, we're plus 1 over 2. So now let's make the same denominator for the exponent. So 5 over 6, I'm going to multiply top and bottom by 2. So -2 minus 2 over 6, and multiply top and bottom by 3, so it's 3 over 6. And when you subtract and add together, you're going to get 5, 6 over 6, which is 1. 5 to the 1, which is 5. Okay. So you're going to do same thing for letter E. Keep in mind, you don't have to change anything with this one. Just remember that the base is -1 over 2, because all three of them have the same base. But this time, you're subtracting it because you're dividing. So -3 minus 5 minus -11. So the base stays the same. Oops. So -3 minus 5, which is -8, and negative becomes positive. So it becomes -8, negative becomes positive 11. So therefore, -1, 1.5 is going to be 3. And just punch it in your calculator. So what you're doing is you're doing this times 3 times by itself. So you will get -27 over 8, or you could put it in a mixed fraction, -3, 3 over 8. So try to use a calculator when you're doing this. Okay. Now, don't worry about scientific notation. We'll omit this for now, so you don't have to know. But let's take a look at number 3b. So same thing. We are going to simplify first and then evaluate by plugging in these numbers. So let's simplify the numerator. So let's do the numbers first. -2 times 6 is -12. And then x, you're going to add 5 plus 6 is 11. And there's nothing for y, so the y stays the same. Over the coefficient, it looks like it's 4 times invisible 1, so just 4 stays as it is. There's nothing for x except for x3, so x3 stays the same. And for y, you're multiplying, so 1 plus 2 is 3. And then let's simplify the coefficient. So -12 divided by 4 is -3. And then x, you're dividing, so we'll have to subtract. 11 minus 3 is 8. And then y, 4 minus 3 is 1. Now, we just simplified as much as possible. And then let's plug it in. So instead of writing x, I'm plugging in -1 into x. And for y, I'm plugging in 4. And it looks like -3. So -1 to 8 is going to give me +1 times 4. And when you multiply all together, you're going to get -12. And we just finished evaluating. So this should have been reviewed from lesson number 1. Now, something new is that if you have a power of power, so exponents are right beside each other like this, what you're going to do is you are going to multiply. So it's 2 to the 2 times 5. So it's 2 to the 10. Y, 5 times 4. So it's y to the 20. So when you have exponent right beside each other with a bracket, you multiply the exponent. So to simplify a power of power, I'm going to put a star here. You're going to again keep the base, but this time you're going to multiply the exponents. So let's try an example like letter B. So what you need to do, they're right beside each other. So you're going to do 1 over 2 times 10, which is 1 over 2 is like 0.5, right? So 1 over 2 times 10 is going to be x to the 10 divided by 2, which is x to the 5. For letter C, we have the triple of a power. So what it is, all you need to do is just multiply. Same rule applies. So it's 2 times 3 times 4. So when you multiply all three, you're going to get 9 to the 24. Okay. Now, what about letter E? So for letter E, what you could do is you could multiply like this to the top and bottom, or you could simplify what's inside the bracket first. So because these two are the same base, I'm going to divide them. So it becomes A8 minus 4, which is a to the 4, 6. And then you multiply. A to the 4 times 6 is 24. Okay, so do the bed mass where you do the brackets inside the brackets first, simplify, and then you do the exponent. Same thing here for letter F. I'm going to do the brackets inside the brackets first. So collect the like terms by multiplying. So I'm going to add the exponents. Y to the 6 over y to the 5, 7, and 8. And then I'm going to multiply the exponents. Y to the 48 over y to the 35. And then we are going to subtract. We're dividing. So it's y to the 48 minus 35 is going to be 13. And that's your final answer. Okay. Now let's try the next one. Number 2C. Okay, so let's try number 2C. So it looks like we have a power. So I'm going to simplify the numerator first. So because they're right beside each other, I'm going to multiply. So 5 to the 10, and there's nothing power of power for 3, so 3 to the squared. Okay. And then over, they're right beside each other, so 3, -1 times 2 is -2. And then 3 times 3 is 9, 5 to the 9. So now I wrote 5 to the 9 outside the bracket, or if you want, you could write it inside the bracket. It means same thing. And then after that, I hope you know, you can see that we have a like term, 5 and 5, the same base. and 3, and 3, same base. So let's do 5. So it looks like 5, 10 minus 9, because we're dividing, is 1. And 3, 2 minus negative 2, right? Because we're dividing, so we got to subtract the negative 2. But negative negative becomes positive. So it's 5, 3 to the 2 plus 2, which is 4. Okay, and then we could simplify further. 5 times 3 to the 4 is 81. Therefore, we can evaluate it to be 405. Okay. So same thing. Now number 4, example 4, it says express 64 as a power of base different letters. Okay, so if we're given different letters of a base, so for example, if we want to express 64 as a base of 8, well, we know that 8 is going to be 8 times 8 is 64. So it's going to be 8 squared. Okay, so 8 squared is going to give me 64. What about 4? All you need to do is just do trial and error. Is it 4 squared? No, that will give me 16. What about 4, 3? Yes, 4 times 4 times 4 will give me 64. Okay, so we don't want to have like a decimal in the exponent, always a fraction or a whole number. So same thing for 2, you could do trial and error. So it's going to be 2, you could start doing 2 to the 3, or perhaps 2 to the 4, and you will notice that 2 to the 6 will give me 64. So the base of 2 to the 6, it will be equal to 64. And when you're doing the homework question, this is like just a reminder for the measurement, is that in order to find the surface area, well, there are 6 sides to it. So the area of one side is s squared, right? Length times width. But because there's 6, you're going to do 6 times the area of one side. So 6s squared. And for volume, it's length times width times height. So it's s times s times s, which is s cubed.